Hello everyone, welcome to the next session of fluid mechanics. In this session, we are going to start with a discussion on Newton's law of viscosity. Now, Newton's law states that the shear stress tau on a fluid element layer is directly proportional to the rate of shear strain. We have already discussed about the concept of viscosity in the previous class. So you must be well versed with the terms of shear stress, which is applied by the fluid layers on the layer below it or the layer above it. And this tau was directly proportional to the rate of shear strain on the body. So we had already discussed that tau is directly proportional to du by dy, and when I remove the proportionality sign, this can be substituted with the constant of proportionality mu, which is also called as coefficient of viscosity, or it is also called as viscosity. So this was the dynamic viscosity which we have studied in the previous session. The constant of proportionality is called the coefficient of viscosity mu. Mathematically, it is expressed as these two, and you have already studied this. Fluids which obey the above relation, that is this relation, they will be known as Newtonian fluids. And the fluids which do not obey this relation will be called as non-Newtonian fluids. So this is another classification of fluids apart from fluids being classified as liquids and gases simply. So each liquid and gas in itself can also be called as either Newtonian or non-Newtonian based on the law that it is following. It can either follow Newton's law of viscosity or it may not follow. Next, let's talk about variation of viscosity with temperature. Temperature change affects the viscosity of fluid. So if you increase or decrease the temperature, the viscosity of the fluid, that is how thick or thin your fluid is, whether it is liquid or gas, it will be affected. The viscosity of liquids decreases with the increase of temperature, while the viscosity of gases increase with the increase of temperature. So this is something which we will be discussing now. This is due to a reason that the viscous forces in a fluid are due to cohesive forces and molecular momentum transfer. So we need to talk about two principles. One is called as viscous force, which affects the viscous nature of a fluid, and the other principle is of molecular momentum transfer. In liquids, cohesive forces predominates the molecular momentum transfer, which means amongst these two, for liquids, we are going to see mainly cohesive forces predominate. Cohesive force means that there is a liking or attraction between the molecules of the same substance. Suppose if I talk about water in a container, the molecules of water will have more cohesive forces, that is, they will be tightly bound to each other. In a container, let's talk about gases. You will see the molecules are quite far away from each other. That means cohesive forces for gas is less and for liquids it is more. And here it states that cohesive force predominates, which means it is having a more effect than the molecular momentum transfer principle. Now, molecular momentum transfer is very simple. What it means is molecular stands for molecule, momentum is nothing but your mass into velocity, and transfer. We are taking snooker game as an analogy for understanding what is molecular momentum transfer. Let's assume that there are lots of molecules here. This is the ball, but I will say they are molecules. Now you can see with the help of a cue, a person is hitting one ball. So what he does is he is giving velocity to this ball, which is a mass. This multiplied becomes momentum. When this moves with a particular velocity, with a particular momentum, energy, it will go ahead and hit say another ball. When the first ball hits the second ball, it is going to transfer the momentum from itself to the second one. It will not transfer the entire energy, obviously it will transfer some part of the energy. And after some time, it will move ahead and then come to a rest. The second ball will start rolling because it has gained energy or velocity because of this first ball hitting it. This ball say now goes and hits this third ball, and say this ball directly goes into the pocket. So this is how snooker game is played, and same way you can imagine about the molecules in the container that I have shown here. So that is called as molecular momentum transfer. So these molecules, if they are energized, they move forward, they hit the other one and they transfer the energy to the next one. And the next one then goes further and hits the other molecule. So that's how momentum is transferred from one molecule to the other. So in liquids, cohesive forces predominates the molecular momentum transfer due to closely packed molecules. Now you can see in liquids, the molecules are so close to each other, there is no space of this kind of a movement. So what predominates over here is cohesive force because they are very close to each other and the attraction is more. And with the increase in temperature, the cohesive forces decreases. This is something we know. In liquids, when you apply heat, what you will see is these molecules then go away from each other. So the cohesive force is going to reduce and molecular momentum transfer is already not a predominant factor. So there is no question of molecular momentum transfer. So that is why when the temperature increases for liquid, the cohesive force will decrease, which results in decrease of viscosity of the liquid. But in case of gases, the cohesive forces are small and molecular momentum transfer predominates. When you talk about gases, they are already so away from each other that there is no question of cohesive forces. So what predominates over here in the case of gases is molecular momentum transfer. With the increase in temperature, molecular momentum transfer increases and hence the viscosity increases. Now suppose let's heat this gas. When you heat the gas, these molecules, they start gaining energy and they start moving like these balls and they go and hit each other. So when they hit each other, what they are doing is they are transferring the energy. So we say that the viscosity of the gas increases when it is heated and the viscosity of liquid decreases when it is heated because the cohesive force becomes less active at that time. Here you can see the relation between viscosity and temperature for liquids and gases. For liquid, this is the equation that is used for calculating the value of mu. So we can understand that if the temperature increases because it is in the denominator, your mu value is going to decrease. Mu over here indicates the viscosity at T degrees Celsius in poise. T is a particular temperature, say some standard temperature of 20 degrees Celsius. Mu naught is the viscosity of liquid at 0 degrees Celsius, again the standard value. Alpha and beta are the constants for liquid. These are also going to be some standard values which will be always used. So for water, which is a standard fluid, you can see that these are the values that are defined for mu naught, alpha and beta. And for a particular temperature, if you are calculating, you can use these values and you can calculate the value of mu. For gases, this is the equation that is used. You can see for air, which is a standard fluid, mu naught, alpha and beta values are given. Say you want to study it for a particular standard temperature, if you substitute these values, you will get the value of mu. It is clearly written here that equation 1 shows that with the increase of temperature, the viscosity decreases, that you can see from the equation. And in this equation, you can see that temperature is in the numerator. So as you increase these value, mu value is going to increase. So with this, I end the session. I hope you have understood the concept of viscosity completely. In the next session, we will see numericals on the topic of viscosity. If you have any doubts, please write to me in the comment section. See you in the next session. Thank you.